Hello again, everyone. My name is Mitchell Lucas, and I did my activity on comparing the rock cycle to sediment found in different geologic areas. And this activity is made for high school students, grades 9 through 12. I first start off with my introduction, and my hypothesis states by knowing if the area contains igneous, sedimentary, or metamorphic rock, you can better identify the sediment found in the United States or internationally. Then I explain my overview, and I talk about the plate tectonic process, and I state that this process has broken the lithosphere down into numerous plates that move together, convergent, spread apart, divergent, or slide against one another, which is transform. The interaction between these plates increase temperature and pressure, which forms different rocks and minerals. The process of weathering and erosion create the sediment or sand that we find in rivers and oceans. Then I start to talk about igneous rocks, and I explain that this type of rock can either solidify beneath the lithosphere, which is intrusive, or above, which is extrusive. Intrusive rocks are coarse grained, which are formed from the slow cooling process of minerals within the melt. These rocks are generally associated with plate convergence, which can cause intrusion of magma into a solid crust at depth. Extrusive igneous rocks are rapidly cooled and usually cooled due to a volcanic eruption. Divergent plate boundaries are most associated with mid-oceanic ridges, oceanic and oceanic plates that are divergent. These ridges are formed from the upwelling and magma that pushes these plates apart. Then I talk about sedimentary rocks that are formed from the burial of sediment into layers of sand, mud, and calcium carbonate that are deposited on the land or sea. Then I talk about weathering and the physical and chemical processes that break up and decay these rocks into sediments are the sand that we see in these photographs. These fragments are moved to their spot of deposition through erosion. Due to formation, sedimentary rocks can be found in any respective plate boundary. Then lastly, we talk about metamorphic rocks that are formed from high temperature and pressure that cause the rock to change its mineralogy, texture, or chemical composition while maintaining its solid form. These rocks can be igneous, sedimentary, or metamorphic and experience temperatures high enough for the rock to experience recrystallization. Then I state that these rocks are most associated with convergent plate boundaries, but can also form in any area that has increased temperature and pressure. Then I go down here to talk about my procedure. I'll just read it to you. For this activity, I provided magnified sediment sample photographs provided by Charles Lindgren from the Science of Sand. By providing the overview, you should be able to correlate the sediment to its correct rock type, which is igneous, sedimentary, or metamorphic. You should also be able to distinguish if the rock is originated from a convergent, divergent boundary or caused by intrusion. We will not worry about transform plate boundaries because they more focus on the plate's motion rather than the creation of rock. Then we go down to my sediment analysis or my quiz. Then I list my objectives. And the first sample that is in my sediment analysis or quiz is a sediment that was found at Reed State Park in Maine. And we have a description. The sediment contains the minerals quartz, plagioclase, alkali, feldspar, and muscovite. Most of the rocks that make up these minerals contain coarse grains and can be seen with your naked eye. The type of rock that is most relevant in the sample is syenite, which is this one right here, which is very similar to granite, but contains very little quartz and high in feldspar content. Then we go down to my first question, and I state what type of plate boundary formed the sediment. And we know that convergence is the most likely plate boundary. And is it intrusive or extrusive? We know since we can see the minerals with our naked eye, it's going to have to be intrusive for the slow cooling process. Then we go down to my second sample. And this is a pumice that was found from an underwater volcano in Tonga. And I state my description, which is the rock sample contains minerals feldspar, augite, and hornblende. This rock is very fine grained and can have considerable amounts of glass within its texture. The rock seen in this photo is called pumice, which I already stated, and is formed by a very fast cooling process that has made many vesicles or pores within this rock. And then we go down to my second question. What type of plate boundary formed this sediment? And we know divergence formed this. And is it intrusive or extrusive? And due to the fast cooling process, it would be extrusive. Then we go down to my third sample, which was found in Tampa, Florida. And my description, this sample contains minerals quartz and calcite, or calcium carbonate. The grains are very well sorted or sub-rounded to rounded. This angularity of the grains shows that the sediment traveled a great distance before it was deposited. And the third question, what type of plate boundary formed the sediment? And we know, since it was a sedimentary rock, that sedimentary rocks can be found at all plate boundaries. And did this sediment get deposited from a river or ocean? Since it was well-rounded grains, we will say that it has been deposited by an ocean. Then we go down to my last sample, my fourth sample, and this is my sample from the Coe River in Tennessee. And we go on to the description. And the sediment in this sample contains the minerals chlorite, quartz, feldspar, biotite, muscovite, and pyrite. The rocks within the sample consist of limestone, shale, and sandstone that have undergone increased temperature and pressure. This caused these different rocks to change mineralogy and texture. And we go down to my fourth question. What type of plate boundary formed this sediment? And convergence was the most likely plate boundary. And can oceanic plates be metamorphosed? And we say yes, they can, because whenever two oceanic plates collide, the denser, usually older oceanic crust is subducted. And that would be my last question of the quiz, and we have my answer sheet. And we'll go on to my references. And that is the end of my activity. I appreciate you guys listening to me, and good luck with the rest of your semester. Thank you very much.